Hello, Chikon. Sorry I can't be there in person, but lockdown is what it is. So we'll see how we go with this one. Okay, so my name's Tom. I am not a lawyer, as the slide says, but I am an embedded software engineer. So while I talk, I will put this up so you've got something to look at. Yeah, so I've been an embedded software developer for over 20 years, and for the last 10 years, embedded devices have become more and more connected. And effectively, embedded connected devices are IoT devices. You can spend a few hours arguing about the difference between the two, but effectively they all come under the heading of IoT. So as I said, I'm a developer. I work for a company called Technique, and we design cameras for other companies, companies that don't have their expertise or the resource to be able to do it themselves. And most of these cameras are connected in some way, Wi-Fi, Bluetooth, 4G. There's pretty much always a connection to the outside world, which basically means they're IoT devices. And more, we're starting to see customers come to us with requirements of projects that need to meet various IoT legal standards for security. This is precisely to prevent the kind of thing you're seeing in the little comic up there. But I wanted to talk a little bit about the requirements that we're getting from customers. And this isn't new. This has been happening for the last year or two. But hopefully this is starting to help protect us from the worst cases of IoT insecurity. So firstly, our old friend GDPR. GDPR came into force in 2018, so it's been around for a few years now. Really covers any organization collecting data to do with EU citizens, but because it's difficult to say where EU citizens are and what products get sold in which part of the world, it's generally sort of regarded as something you want to try and meet wherever your products are being sold. So it doesn't really say anything specific about IoT, but it does say a lot about how you collect and store consumer data. As you can see there, it talks about pseudonymization, encryption, confidentiality, all of those kind of good things to do to make sure that people aren't stealing your data. And it enforces this with a series of fines, and they can get pretty high. So you want to try and avoid that as much as possible. So as I said, GDPR doesn't really talk about IoT specifically, but it does talk about data. And what we're starting to see now is customers talk about handling data in a way that means it can't get stolen or leaked. And you're starting to see things like this, where you've got some kind of IoT device, you set it up using a phone, and the app on the phone generates an asymmetric key pair. It sends the public key to the device. The device then uses that public key to encrypt data that it pushes up to the cloud in some way. The phone then pulls that data down, and it uses the private key to decrypt the data and show it on the phone. So even if your cloud system gets hacked, or the end device or anything like that, the person hacking that, as long as you've done a good implementation, can't view the data. It's only viewable to the end user. And I thought this was only a sort of theoretical concept. We've talked to a few customers about this, but quite recently I saw Tesla rolling out this new feature on their cars. You can basically view the car's cameras on your phone to see if anyone's standing next to the car before you walk out to it. And it says end-to-end encrypted. Now, I haven't looked into the implementation, but the idea here is that you pair your phone to the car and only you can view that encryption feed, that encrypted feed. So it's a similar kind of concept. It's the kind of thing you might want to look at doing to make sure that your device doesn't infringe GDPR if it gets hacked. Secondly, California Senate Bill 327 or SB 327. This one's a little bit newer, came to force on the 1st of January 2020. Now, amazingly, for a piece of legislation, it's extremely short. It's only about a page long. And really all it says is it requires all IoT devices sold in the state of California to be equipped with reasonable security, except devices that come under federal law, for example, medical devices. But yeah, what does reasonable security mean? I mean, the only thing it explicitly spells out is really about passwords. Either the password has to be unique for each device, or the device forces the user to generate a new password when they first set it up. And that's it. And everything else is just kind of that phrase, reasonable security. So I suspect that what's going to happen here is that we're going to see legal cases that enforce this kind of set up precedent. So if someone brings a legal case, then there may be precedent there for what device may infringe this bill. The other point to make here is that California is only one state in the US, obviously, but it's a pretty big state. And suppliers, when you make a product for the US, suppliers really don't want to have to differentiate between states when they sell products. So if you're selling a product in the US, it really has to meet requirements for all 50 states. So this is effectively saying that any product in the US really needs to meet this requirement. But as I said, it's a bit vague about what this requirement is. And I had a look around. It's been enforced for just over a year and a half now. And I had a look around and I couldn't find any examples of this bill really being used. The only one I could find a reference to was the Vicada hack, which was in March. A whole bunch of security cameras online got hacked. And there was this article that mentioned that SB 327 could be used to prosecute this company. I haven't seen anything else apart from that, but again, one to keep an eye on because those precedents will come into force, will establish what force can be used against companies that infringe it. So the other one we've been asked to look at is what you may not have heard of, but it's starting to become reasonably common. We've done a couple of products of this. This is FirstNet. FirstNet was first discussed in response to 11.9, which in the US is known as 9/11, which highlighted the inability for deployed public safety networks to handle a true crisis situation. Basically, what happened was the mobile phone networks went down. Everyone was trying to call their mum, and the network couldn't handle it, and nobody could use the phones. So the idea is to set up a separate mobile phone network for first responders. And the contract was finally awarded to AT&T in 2017, and it uses a separate band in the US, band 14, which isn't used by any other mobile phone network. And basically, you just have to be in one of these groups: law enforcement, fire, emergency, medical. You have to be in one of these groups to apply to get a SIM card on FirstNet. And then you put that SIM card into your phone or a device, and you get access to this specialized mobile phone network. And they also provide the ability for things like mobile cell sites. So you see somewhere areas where they have a forest fire or something like that, possibly in an area where there isn't very good cell service. You can take a mobile cell site for FirstNet out there, and all of the first responders who've got FirstNet devices will be able to connect to that and get access to mobile phone network, and obviously to be able to communicate with each other. And it's not going to get used by, a local teenager trying to watch Netflix or something like that. So it preserves your bandwidth. FirstNet, obviously, it's somewhat specialized in its first responders, but it also is relevant because it's a pretty good security requirement. I will go into that in more detail in a minute. But so when other government departments are looking at purchasing equipment, they may well look at FirstNet certification and say, well, this is obviously a good product because it's already passed FirstNet. You also get quite a lot of consumers, especially in the US, who like buying products that are approved for use by police and emergency services because they think that's a good mark of quality. So what kind of things are we talking about here? Well, obviously there's the phones themselves, but there are other devices that will connect to FirstNet as well. And the most known one is these things, body cams. So the first generation of these didn't connect, but the newer ones do. And the idea is there that they're constantly uploading the video either as a live feed or as a post-processed buffered feed to the internet. So if the camera is broken or something like that, you still capture the video data it was recording. You can imagine a situation where the police officer says, oh yeah, I lost my camera because the person we were reaching struggled and then they accidentally fell out a window and we don't know what happened. Or a police officer goes missing and you're trying to find out what they were up to before they disappeared. So that's the idea of being able to upload from body cameras. So what security requirements do you have to match to be able to sell a product on FirstNet? Well, there's a list of 30 security requirements. And I'm sure you can read that because the text is quite small. I'm not going to attempt to go through every single one because it's a relatively short talk. What I have done is broken them up by the OWASP Top 10 for IoT vulnerabilities, which was last updated in 2018. It's still reasonably up to date in terms of what IoT devices are most vulnerable. So I've basically split them up into these just to give you an idea of how they affect the different areas where IoT devices are vulnerable. So number one, weak, guessable, or hard-coded passwords. Oh, and by the way, I'm not attempting to say that these are the exact definitions and everyone should listen to me. If you quibble about the way I've laid these out, then feel free to come and chat to me afterwards. But I tried to break them down to make it a little bit more obvious. So yeah, weak, guessable, or hard-coded passwords. You mustn't have hard-coded credentials across all of the devices. The credentials need to be reasonably complex. They need to be non-unique if you do a reset, and there needs to be some sort of limitation on the number of times you can log in. Pretty basic stuff. Insecure network services, again, only want to enable the network services that are actually relevant on the device. You need to make sure that they're all checked for vulnerabilities. You need to make sure it's secure. Oh, sorry, I hit the button. You need to turn off remote login and those kind of things by default, and you need to make sure your web APIs are secure. This is pretty standard stuff, but as I said, it's laying it out in some detail. Insecure ecosystem interfaces. So pan-LAN wireless connections use best practice authentication encryption measures. I'm still not entirely sure what best practice is in these kind of situations, but I mean, you just need to do a reasonable job. Management connections to external services. This is all pretty standard stuff. Lack of secure update mechanism. This is a really key one. You need to have a secure boot process. The firmware files need to be transferred securely. If they're publicly accessible, they need to be encrypted at rest. You can't just pull them apart. They need to be digitally signed and validated, and they need to update remotely by default. Obviously, you can have some way of asking it not to update during the day or something like that, but you have to know that those updates are going to be applied whatever the user does. Use of insecure or outdated components. This is also a really key one. You need to make sure that open source libraries are invented and tracked. You need to make sure they're up to date. You need to test the system software for vulnerabilities. You need to turn on the security hardening in the OS. You need to have some way of reporting issues. You need to have a way of actually checking your devices. So this probably means you're going to be bringing in an external pen testing company. And finally, you want to turn on all of the compiler and chipset hardening. Now, the ones who haven't fallen asleep there will notice I just skipped over 6, insufficient privacy protection. As I said, I just broke up the 30 into the most obvious ones, but you could certainly say that some of these would address privacy protection as well. So number 7, insecure data transfer and storage. Don't send data clear text and don't store stuff clear text on the device. Pretty basic. Number 8, lack of device management. This is more of a first responder type thing because you wouldn't expect this so much for consumers. But obviously, you want to be able to change the logins. A compact sliver is required. You need to be notified of potential security issues and updates, and you need to have some way of logging security issues and system faults. Again, I skipped over number 9, insecure default settings, but some of these apply anyway. And then number 10, lack of physical hardening. You need to make sure that the various debugging interfaces on the hardware are actually disabled, so you can't just plug in a JTAG and pull all the data off the device. So that's basically the 30 requirements you've got there. Now, the interesting thing about FirstNet is these are ongoing. So I've highlighted a few of the issues here. You need to make sure that your open source libraries are tracked for new vulnerabilities. You need to make sure they're up to date. You need to have a plan for remediating this stuff. So you're starting to talk about things like, I think GitHub as a way of telling you what vulnerable libraries you're using. You can use something like SNCC. There's the OWASP dependency check, which is a free tool to be able to do this. Basically, it looks at your build system, tells you what, finds out what libraries you're using, and then looks at those libraries against a list of CVEs to see what vulnerabilities are being published. So the idea here is that if you get a new vulnerability against something you're using in your software, you need to update the software and you need to release that in a reasonable time. You also have to have ongoing pen testing being done. So basically, it's a kind of rolling thing. You're not just selling the product. And the other thing that's noteworthy about FirstNet is this kind of idea of saying, oh, I've raised an issue against your device, and the vendor comes back and goes, oh, it's obsolete. We're not going to fix that. You can't do that with FirstNet because the FirstNet requirements are reviewed every year. Now, I've looked into the documentation around FirstNet. I haven't actually specifically found anywhere that says if you failed the requirements a few years after you release a product, that they would actually block the products then. But you certainly wouldn't be able to sell them with FirstNet written on them anymore. And if they did actually block them from the network, I'm assuming that unless you've made it very, very clear when you sold the products that you're going to be facing a few lawsuits from the companies you sold them to. So FirstNet, it gives you a pretty good standard for security on IoT. It's certainly higher than you'd expect to see on consumer products. This idea of reviewing it every year, you certainly wouldn't get that in the consumer environment. But the idea of laying out all of those requirements really quite specifically gives you a pretty solid requirement for security, far more so than something like SB 327, which just says, hey, make your device secure, and then doesn't really give you any guidance as to how to do that. So those are the three standards that we've been asked to look at by our customers. They're not the only standards by any means. So just to give you a rough idea, this is a diagram. I actually came across this last night that shows how all of the different standards for IoT that are currently out there interact. And I'm not even going to attempt to read it because you can see how complex it is. So some of the other standards you'll start to hear about in IoT are the European standard. This was come up with by the European Telecommunications Standards Institute. It's not mandatory yet. So this is just a general guide for people who want to sell products. And the idea with the ETSI standards is they're open standards. They can be adopted by countries or other individuals when you want to. It's almost like having an open standard. So you're starting to see this. This will probably be adopted by the European Union, but you're also starting to see other countries look at this one. I think the UK are planning to do something along these lines. Obviously, they're not in Europe anymore, so who knows what they're doing. But that picture I just showed you was from this link at the bottom, IoT security mapping. It basically looks at all of the different standards around the world and maps them to the ETSI standard to show which standards are what. So the idea is there that if you meet the ETSI standard, you can basically say you're meeting the standards for all these different countries at the same time, which makes things a lot simpler. The other one I've seen is the Australian standard. Again, this is just a guidance document. It's not mandatory yet. I also don't, it's somewhat confusing. The IoT Alliance Australia, in the document they publish, they refer to themselves both as IoT-A and IoT-AA. I don't know if that means they're two different things or they're just confused. Who knows? But they published a guideline. It's kind of hard to break it down into different pieces because they've just basically linked to a whole bunch of different other standards. But you'll almost certainly see the Australian government bringing in some sort of standards for these things as well. So that's basically it. These are the standards we're seeing come in. Customers are asking us to address. And I'm sure that some of these will become mandatory over time, but it gives you a rough idea of what you're starting to see in the IoT space. Okay, that's the end of the talk. Thank you very much, and I hope you enjoy the rest of the conference.